y-axis and x-axis on here so I can see it a little bit easier. So here's my x, here's my y. And then we're just going to take care of each individual graph as we go along here. So let's say that my first graph is this one right here in the red highlight. That one says that I have a y-intercept at -3, so I put a dot at -3. It then says that I'm going to, from that point, go up 8, right 5. So 3, 4, 5, 6, 7, 8, and then right 5, 1, 2, 3, 4, 5. I put a dot. I look at the symbol, and it says greater than or equal to. So when I see greater than or equal to, that means I'm going to have a solid line. So I graph a solid line between those 2 points. And as for the shading, I see that it says greater than or equal to. That means I'm going to be above the line. So this is my shading for the red line, or inequality. Let's talk about the last 2 inequalities before we get to the middle 2. The very last one says x is greater than or equal to 0. So whenever you see an x thing, like x equals 7, that means all of your x values are 7. In this case, that means all of your x values are 0. That basically is talking about the y-axis. So if I'm going to graph that inequality, x greater than 0, that's talking about the line that goes along the y-axis. And I noticed that it said greater than or equal to, which meant it was solid. So it's talking about all of the x numbers that are bigger than or equal to 0. Or in other words, it's talking about all the lines, or points, excuse me, that are to the right of the y-axis. The second one from the bottom, this one, y greater than 0, basically means you want all of your y values to be more than or equal to 0. That's talking about the x-axis. That's this axis right here in the pink. And notice how it was greater than or equal to, which means it was solid. And then all the y values that are greater than or equal to 0 are talking about the positive ones as well as 0. So you shade above the line. So this really just eliminated that tiny little triangular region just below the x-axis that was in our feasible region but is not anymore. So that's already gone. Is the third one from the bottom is the next one that I want to talk about. And it says y is greater than or equal to 1 minus x. The y-intercept for this is a 1. That means on that y-axis, that color is not so good, is it? Do you guys see that brown okay?
Where is it?
Right here? No? So let me pick it. What color should I use?
Black. Gray.
Black sounds good. So in the black now, here's my solid dot. It tells me I'm going to go down 1 over 1 because the slope is -1. So these are the dots right here that I'm talking about. And since it's a greater than or equal to symbol, that's a solid line. So it looks like this. And it says to shade all the ones that are greater than or equal to. Which means now, when I shade, that's talking about this region up here. And you can see that this has sliced off still yet a tiny, tiny sliver down right by where the x and the y-axis cross. So now I have the shape that goes down the blue line, right down by the black line, horizontally across the pink and up the red, up in between all those regions. And then the last one that we're going to talk about is the one with the squared thing in it. This shape is a parabola, and we kind of talked about how if you know the shape of a parabola, what ends up happening. And what I notice, first of all, is from the inside of the parabola and from the outside of the parabola, my vertex is going to be at 2, 4. These were the transformations we had talked about a long time ago. So up 1, 2, and right 4. 1, 2, 3, 4. So here's the vertex. No, that's not right. Pardon me. What I meant to say is right 2, up 4, right 2, up 1, 2, 3, 4. Here's the vertex of my parabola. So the 2 and the 4, this meant to go right 2, in case you forgot from a while back when we did this, and up 4. We did this in transformations, like one of the first units that we talked about. And then, do you see the negative sign that's in the front of the parentheses? What does that tell me? It's flipped. It's upside down. So now I go over and I draw my parabola upside down. And so here's my parabola upside down. And notice how the region has really been restricted. This says less than or equal to, and when I shade the less than or equal to, that's the stuff inside the parabola because it's saying do it under that parabola. So the only part that is the feasible region now, just for fun, I'm going to put it in green so you can see it. This is all that they're talking about, like all the overlappings together is in this green highlight. So all of those restrictions narrowed down my feasible region to this area. Let's look at number 6 first, and we'll come back to the word problem in number 5. In number 6, it says to write the inequality of this particular graph with its shaded region. So if I want to write this inequality, the first thing I probably should do is I probably should take a look at the line that they give me. Is this line dotted or solid? Solid. So that means that I know that it's going to have an equal sign on the bottom. So already I put the equal sign. Is the shading above or below? Below. So that means I'm going to have a less than symbol because it's under the line. I know that I always have a y there. And I'm looking for the y-intercept. Where's the y-intercept? 1.5. So I put down here, because my y-intercept is at 1.5, I put down 1.5 for the y-intercept. Is the graph going up or down? Up. So that means I'm going to have a positive slope, and I know there's going to be an x. And then I just have to figure out how to get to the next point. So if I look at what's happening to the next point, maybe I say I'm going over here to the next point. It looks like I went up 1 unit and right 2 units. So up 1, right 2. To get to the next place. Okay, the last problem is that dreaded word problem that a lot of people freak out about, but I kind of like because it's trying to figure out a puzzle. And so on this one it says Rachel has 3 hours to do on her homework. And she has to do math and chemistry. And she's got to spend at least a half an hour on chemistry. We're going to define our variables and then say the constraints algebraically. So let's talk about how we do this. First of all, if I'm talking about chemistry, let's say that since they mentioned we'll just say X is chemistry. So when we talk about chemistry, we know we're talking about X. And let's then make, I guess, Y would have to be math. And we know, let's see, they said something about how much time. Oh, here we go. It says that she has to spend at least a half an hour on chemistry. So if I'm doing at least a half an hour on chemistry, which was X, has to be at least, in math means greater than or equal to, and then a half. So that's the purple highlight. And then it says she has to spend more time on math than chemistry. Duh. So if you want to spend more time on math, which was y, that has to be more than chemistry, which was x. So in the purple, at least a half an hour on chem, but more time on math than chem in the orange. And then the last thing it says is the very beginning thing where they tell us that she has 3 hours to work on both. Bless you. So she doesn't have more than 3 hours. So that means that together, the chemistry work plus the math work cannot exceed 3 hours. So altogether, they can only have 3 hours. Now, the purple, the orange, and the gray are the three constraints. But I don't like the way the gray is set up because the y is not by itself. So I'm going to move the x thing to the other side by subtracting off the x from both sides, which means that I would then have y is less than or equal to 3 minus x. And so now you really have three constraints, the purple, the orange, and the gray, that indicate how you're going to shade and draw these things. If I put my axes on the graph so I can see them very well up here, and then we go to the purple constraint to start with, which is saying that my chemistry time has to be more than or equal to a half. This is kind of a not such a great deal. I see a equal sign, which means it has to be solid. So I draw a x line, which is a vertical line, at a half, and it's solid. And this is representing the chemistry. And then I shade greater than that, which means I'm shading to the right of that line. The orange is telling me that I want to spend more time on math than chemistry. I don't see a number on the right side of inequality. That's telling me that my intercept is at 0. So I put a solid dot at 0. And then because it's just an x, that means I have a slope of 1. That means go up 1, right 1, up 1, right 1, up 1, right 1. So I put a series of dots and keep going up 1 and to the right 1. And then I look back at the symbol and I say, is this a solid dot or a dashed line? Dash, because there's no equal sign. So I dash the line or dot it. And then it said I want it to be greater than, so that means above the line. So I shade above the line. And so far, my feasible region is where they overlap, the purple and the orange. The very last constraint is where I can't exceed 3 hours of homework. My life is very busy. So I put a dot on the y-axis at 3 in gray. And my slope is -1, which means go down 1, right 1. So I continue to put dots by going down 1, right 1. And then I notice that it's a less than or equal to symbol, so that means it's solid. So I make a solid line. And I want everything that's less than that line, which means under. And the only region I can choose is where all three constraints overlap. The purple, the orange, and the gray. This is a very small region. So my solution region means I have to be to the right of the purple, I have to be below the gray, and above the orange. So that means this region right here.